Okay, so today's topic is about absorbing states. So before this, we assume that it is possible for the system to go from or to move from another state to another state without any restriction. But there are some cases where once you enter that state, you will remain forever in that state. Means that you cannot go into another state. And this is where we call that you are already absorbed in that state. Okay, so that is about the absorbing state. Okay, and one thing that you have to remember is that in absorbing state, you will have a transition probability of 1. Okay, so this is an example for the absorbing state. Okay, so this is about a debt example. Okay, so you can see whether the customer paid the debt, whether it is 1 month overdue, 2 months overdue, or it takes longer, to pay the debts, or sometimes we just refer it as a bad debt. So now, Azman, the account manager, wants to estimate how many percent, of the bills will be paid eventually, and how many percent of the bills will end up as a bad debt. Okay, so berapa banyak yang dia akan terima from the account receivable, from the customer, and also how many yang akan dikonsider sebagai hutang. Okay, and also from the transition matrix, we can see there is a value of 1 here. Okay, and these two values, for the paid and also for the bad debt is we consider this as the absorbing states. Okay, why? Because the value is 1. 1 means once you enter that state, you will remain there forever. Okay, so kalau ikut logic, once you already paid, then you takkan ada lagi 1 month overdue, 2 months overdue, or categorized as the bad debt. Okay, same goes to bad debt. Okay, it is an absorbing state. So to solve this problem, the first thing that you should do is you have to divide this transition matrix into 4 submatrix. But before you divide, notice here we combine the paid and the bad debt together because they are absorbing state. So we combine these two together, and the remaining is for the 1 month overdue and the 2 months overdue. Okay, so you combine the absorbing states together, then we divide into 4 submatrix. So the first one is the identity matrix, 1001 identity matrix, and the second one is the zero matrix. Okay, just put 0 here. Okay, this can we just put a single R here. Okay, so R here is the matrix containing transition probabilities of the debt being absorbed in the next period. Okay, so you have 1 month overdue, 2 months overdue. Okay, it is being absorbed in the next period. And finally, this is the Q matrix. It is a matrix containing transition probabilities for the movement between non-absorbing states. Okay, because before this, for PMB, so these two are the absorbing states. So now these two, 1 month overdue and 2 months overdue is non-absorbing state. So we want to see the movement. So in summary, we can say that our matrix, our transition matrix, have been rearranged into this form, I, O, R, and Q. So for the next stage, we want to find the fundamental matrix. So this fundamental matrix is the inverse of I minus Q. Matrix, the identity matrix minus Q. Take the inverse. Okay, so please recall the formula for, in order to finding the inverse, okay, for a 2 by 2 matrix. Okay, so originally you have this, okay, A, B, C, D. So in order to find the inverse, you just have to replace the position of A at D. Okay, so now D becomes here, and A replace the A replace D, and then for the B and C, they will remain there, but you have to change the sign. Okay, that's why B and C will remain here, but you have, before this you have a positive sign, now we have negative sign, so you just have to change the sign, and then divided by R. So in order to calculate R is AD minus BC, so you just have to times AD and minus B and C. Okay, that's how we calculate the inverse for 2 by 2 matrix. Okay, so back to our fundamental matrix. Okay, so fundamental matrix, I minus Q, the identity matrix minus Q. So you have 1, 0, 0, 1 minus, for the Q, 0, and then 0 0.3. This one is supposed to be 0 0.3. Okay, and then 0, 0. Okay, so when you minus these two matrix, it will be 1, negative 0 0.30, 0, and 1. And then you have to find the inverse. Okay, so like I said before, for the inverse, for the R, okay, for the R is AD AD minus BC. So in this case, A times D is 1, and then B times C is 0. So 1. So for every element in that matrix, we will be divided by 1. So that's why dia akan dapat itu juga lah. Okay. And then we replace the position of A and D. So it's the same, still 1 and 1. And then for B and C, you change the sign. So in this one, 0, so maintain 0. This one, negative 0.30, now it becomes positive 0.30. So that's why for the fundamental matrix, the inverse is this one. Okay, now for this fundamental matrix, okay, fundamental matrix. So this matrix, so this is our fundamental matrix. So this fundamental matrix indicates or give the expected number of times the system will be in any of the non-absorbing states, okay, in this case 1 or 2, before absorption occurs. So in this case, before the debt becomes bad debt or it is paid. So by looking at our matrix here, okay, the fundamental matrix in this example, we can say that if the customer is in state 1, okay, so in our example, state 1 here is the customer is 1 month late in paying the debt, okay, 1 month overdue in paying the debt. So if the customer is in state 1, the expected number of times the customer would be 2 months late, okay, in means that 2 months overdue is 0.3, okay, before the debt is either paid or become bad debt. So next step, we have to multiply this fundamental matrix with R matrix, okay, where R matrix is the matrix containing the probabilities of the debt being absorbed in the next period. Okay, so we just take the fundamental matrix, okay, times with the R matrix. Okay, so fundamental matrix, now we have 1, 0.3, 0, 1, and times with the R, 0.7, 0, 0.5, and 0.5. Okay, so we have the value for F times R matrix. Okay, and this F times R matrix represent the probability that the debt will eventually be absorbed. Okay, given any starting state. Okay, it doesn't matter whether it is from the state 1 or state 2. Okay, so F times R matrix give the probability that the debt will eventually be absorbed. Okay, so for this example, if the debt is in the first month, okay, so there is a 0.85% that, sorry, there will be 0.85 probability that it will eventually be paid, and 0.15 probability that it will result in bad debt. Okay, so macam sama juga if currently we are in state 2, okay, there will be 0.5 probability that it will be paid, and 0.5 probability that it will become bad debt. Okay, so now back to the A to Z company. So suppose that they have 4,000 account receivable for the first month and 6,000 account receivable for the second month. So we can determine the portion, what is the portion for this fund will eventually be collected, okay, or result in bad debt by using this calculation. Okay, so 4,000 and 6,000, okay, 4,000 in the first month, 6,000 in the second month, and times the F times R matrix. Okay, so you have 6,400 and 3,600. Okay, so that means out of this 10,000, okay, because 4,000 in the first month and 6,000 in the second month, so altogether is 10,000. So out of this 10,000, okay, the company can expect to receive 6,400, and another 3,600 will become bad debt.